السلام عليكم. بسم الله الرحمن الرحيم. We will continue our third lecture. This is week 9. Well, as you know, last time we talked about approximating a derivative, and we have several formulae. So we have learned how to obtain those one from just any approximation. We did not use, you can use Lagrange interpolation, Newton interpolation, or Taylor series. That's what we did. It was easier. Today we'll talk about integration. Okay, so what is integration? We would like to talk about this integration from A to B and approximate this, how to do it. We'll start with the simplest method called trapezoidal rule. So it's trapezoidal rule from A to B. It is one interval. So it means h here from B minus A divided by 1, which means B minus A. Well, this one can be written this one here like this. So A mean x node, B mean x1, and here is the answer. So what is it here? Well, in fact, here, if we want to talk about it here, this is not equal here. This should be approximation. Because look, we have replaced that one here by this. So it is equal if we use like the easiest one, linear interpolation. Well, here is linear interpolation, so we put it here. Why it is linear? Because very easy to integrate. So just by integrating this one, very easy, just substitute this value here. Well, this one here constant, so the integration is x minus x1. It will be x squared divided by 2. Here is the integration. The rest are constant. And similarly for the other one. And then you have to substitute x1 as x0. When you substitute x1, this will be 0, and this minus this, it will be this one. Minus, substitute x node, you'll get this one. And then simplify this one here. Remember that x0 minus x1 equal minus h, and x1 minus x0 equal h. So here is the answer, which means trapezoidal rule. Remember this, x1 minus x0 is h, so it can be written like this. So you're right, what is f of 0? It means the point here. And f of 1 here, so you can write it also. This is b minus a times f at point A divided by 2. And in that case, we have obtained this called trapezoidal rule. How to find the error here? Local truncation error. If you continue integrating here, because when we put this one here, we have something here we've lost. As you remember from a Newton method, which is like a2 times a bracket, f second derivative, and then if you put it here and integrate it, we will obtain this is the answer. Anyway, now we can remember this one just to know. It's important because we can guess the error. So this is really something we have to know. All right. So now if we continue next page, how to continue next page. All right. Now, we are trying to fix it. Okay, here we are. Okay, now we'd like to take an example here, integration sine x dx. This one. Well, this one, if you say trapezoidal rule, it means f at this point, f1 plus f node, or f node plus f1, and here b minus a, which means this one divided by 2. What is f of 1? It is sine of 1. What is f of 3? Sine of 0. Use calculator, you'll get this is the answer. In fact, in this case here, we should be careful here. This is equal. This is again here, this is approximation. Okay, it's not equal because we approximate this answer. And here is the answer. Just to see how good we are, we can obtain the exact value, integrate sine x dx, we get this is the answer. And the error is this one, exact value minus this one. So this is the error, which means our approximation is reasonable. Now, if you want to do another example, like this one, e minus x squared dx, we'll do the same things here again. F at this point and at this point, f of 2, f of 0, and here 2 minus 0 divided by 2. Substitute here the approximation. But in this case, we cannot approximate the exact value. Why? Because ex squared, e minus x squared dx, we don't know how to find it. We don't know the exact value. There is no antiderivative of this function here. So in that case here, we have to accept this. But we must estimate the error, as we'll explain later on. Okay, so now continue if you want to do this example. Another example, I leave it for you, you can do it. Okay, so in that case here we are, well, again, want to go to next page now. Okay, here we are, next page. Same things like as before, but now something called Simpson rule. What is Simpson rule? Well, that one was f of a plus f of b and h divided by 2. Now it is here in the middle, a plus b divided times 4. This is called Simpson rule. How can we derive this one? The error here, local truncation error, this one here. Well, how do you derive this one? Just like before, but now we use a quadratic interpolations, or Gauss, or Newton interpolation, or any other interpolation. But for this problem, maybe it is easier to go to the general interpolation. What is the general interpolation? Here, f of x, this one should be, again, is approximated by this one. F of x is approximated by this. And then we write f of 0. So clearly now, if you substitute 0, we'll get this one here. If you substitute h, we get this one here. If you put minus h like this. In fact, we change it from this to this. Here again, equal. We could it simpler to put it from minus h to h. So we transfer this. In fact, this one here should be different because here this quadratic. Again, this is here approximation. So it's not equal. If we want to write here approximation, here it is again. So this approximation, and just as a quadratic equation, easy to integrate. When we integrate like this, substitute h minus h, we get this is the answer. Again, here is this approximation, this one. It's not equal. So to know this answer, we have to know C and E. What is C? Well, C is given here. Here it is, C. And what is the other one here? B. We don't need B, so no need to calculate. We need A. How to find it from here? So these here two equations, if you add them together, you can see this one cancel this one. So in that case, when we add them together, here they are, we get this one. And from here, it is easily to see 2a equal left-hand side minus 2c, which we know now 2c. It's this one here divided by this. It means we found. Now we go and substitute in 1. Where is 1 here? Here it is. And we found this one. This is the answer. Simplify this one. Just you can do it, good exercise. And then you will reach the answer is here. Remember that here. So we have to put it back. In fact, this one here is approximation is not equal. This approximation and this equal here. So we put it back. In fact, it should be here. When you write AB minus h function should be changed. But we put it back so everything remain correct. So in that case here, this one again, it should be here approximation. This one here approximation. So we write it like this here, approximation. So that is here. So this one is same as this one here. This is called trapezoidal rule. Okay, now let's use it again. Okay, here we are. So here are 3 examples. This one, this one, this one. We have used this one here before. Okay, you can use the other one. So like this one here as before, if you see H here, trapezoidal rule always we have 3 points. 1, 2, and the one in the middle. So it's always 2 here, 1, 2, 1 in the middle. So H equal this number minus this number divided by N. N is 2. So B minus A divided by 2, here is the answer. So in that case here, it's not difficult now. This is Simpson rule equal f of 0, f the last one, and the one in the middle. But this times 4, this one, 1, and here divided by this one. So just substitute these values here. we found the function, and here is the answer. Okay, you can calculate the error. This one also, we know the exact answer, is tan inverse x or arc tan. Here is the answer. I mean, you can calculate the error if you want. So in that case here, let's go here, next one. Now here again, if we make this one here, this is again Simpson rule. So this is Simpson rule. Again, like before, we calculate this. You remember last time we used trapezoidal rule. Now, again, if you calculate the error, oh, the error is much smaller. Why? Because Simpson rule, if you remember, the local transition error is h power 4, or power 5, sorry. But trapezoidal one is much larger than this one. So if we do this again here, we will do the same. It is nice to leave it for you as exercise, and this as exercise, this exact value. But this one here, we don't know the exact error. So if we don't know the exact error, we would like to estimate the error. But anyway, here is again for Simpson rule. It's not difficult to find this one here. It's good exercise to do it. But here we cannot find the exact error, so we have to estimate the error. So in that case here, let's go next page here. And just if you do, this is the error here for trapezoidal rule. And this is the error. So here's power 5 h mean it will give you better answer. Just imagine that h is 0.1. Power 5, it means 0.401, but 0.1 here means 0.201. So this one much smaller. Of course, depends on the second derivative, as you can hear, fourth derivative, and this one. So how can we estimate this one? Well, just we need to calculate here the second derivative for the first one, but the fourth one is fourth derivative. First one, because we are talking about a function here, integration sine x, so eta between 0 and 1. So here, let me do it now. Oh. So this one here, eta should be something we don't know. It is between 0 and 1, but we know the function. So second derivative, sine or cosine, it means the largest value is 1. And fourth derivative, also sine or cosine, the largest value is 1. So because we don't know what is sine eta or cosine eta, because eta is unknown. But we know the largest value is 1. So here, local error is h cubed divided by this times this one, and here this one times h power 5. But I think here we can see this one because this we are integrating from 0 to 1, I think here it's from 0 to 1. So h for trapezoidal rule is really 1 minus h is 0. So this one I think is wrong here. No need to write 8. So the answer is 1 over, so this 1 over 12. Okay, it is anyway, it is much larger than this one. Really, now, in that case, yes. Simpson rule give you less error, much smaller than this one. In that case, it means it is much better than the other one. And now, what is next now? So we have a feeling here, depends, the value depends on h. When h is very small, we get good answer. So how can we make h small or small enough to get good accuracy? This is the talk of next lecture. We'll try to start later. Thank you. Wassalamu alaikum.